Hello and welcome to Add-on. So, have you ever wondered what makes a nucleus behave the way it does? How do all those tiny protons and neutrons stick together so closely and yet they are stable? So, today we are going to learn about one of the classic models used to explain the nucleus, the liquid drop model of nucleus. This model, proposed by the brilliant physicist Niels Bohr in 1936, draws a fascinating analogy between the nucleus and a drop of liquid. Interesting, right? So let's explore why. Alright, so picture this. What do you think would happen if you took a drop of water and zoomed in onto it? Imagining each molecule interacting with those around it. Any guesses? Exactly. In a drop of water, each molecule is tightly packed and held together by forces of attraction, which are short range and very strong. Well, it turns out the nucleus behaves in a similar way. Niels Bohr suggested that the nucleus made up of protons and neutrons, what we call as nucleons, acts a lot like a liquid drop. So let's see why. Okay, let's go over some of the key concepts of how the nucleus and the liquid drop are similar. And by the end of the video, you will see how insightful Bohr's analogy were. So, first question for you. What shape do you think a liquid drop naturally forms if it's in a stable state? Spherical, oblong, flat? Right. A stable liquid drops usually form a spherical shape. Why? Because of surface tension. So let me draw one for you. So because of surface tension, the forces that pull the molecules at the surface inward, creating a symmetry and rounded shape. Now here is where the cool part is. The nucleus also tends to be spherical in its stable state. This is due to the balanced short-range forces between the nucleon and what are the nucleons, neutrons and the protons, much like the surface tension in the liquid. But surface tension does not just shape the drop, right? It also creates kind of a barrier. In the same way, the surface of a nucleus has a barrier that holds its nucleons inside. This boundary is not as obvious in a liquid, but we can think of it sort of like a nuclear surface tension. Isn't it fascinating to think about an atomic nucleus having similar traits as simple as a liquid drop? Now imagine this. What do you think would happen to the drop if we started adding heat to it? What happens when we heat up water? Exactly. It evaporates. The added heat gives energy to the molecules, causing them to break away from the drop and escape as vapors. So this is just like what happens in the nucleus. If the nucleus gains energy, say from an incoming particle like a neutron or proton hitting it, it forms what we call a compound nucleus. Now, what is compound nucleus? This nucleus has extra energy, and having extra energy makes it unstable, releasing nuclear radiations. And this is similar to the effect to a heated liquid drop, but with particles leaving the nucleus instead of molecules evaporating. Right? Now, for the final similarity, we have, and this one is interesting. Think about the molecule in a drop of water. They're constantly moving, right? Bumping into each other and transferring energy back and forth. Well, the same thing happens inside the nucleus. The nucleon, that is the protons and the neutrons, collide and exchange energy. And this happens very rapidly. Now, here's a tricky one. If one nucleon at the surface of the nucleus gets enough energy during this collision, what do you think might happen? That's right. If a surface nucleon gains enough energy to overcome the binding force, the nuclear glue, if you will, it can break free and leave the nucleon. Just like how a molecule might escape from a heated liquid drop. In nuclear terms, we call this particle emission, which is a common phenomenon in nuclear reactions. So, to sum it up, the liquid drop model helps us visualize how a nucleus functions by comparing it to a liquid drop. Here are the key similarities. The nucleus and the liquid drop are both spherical and in their stable state due to surface forces. Just like how heat causes evaporation in a liquid drop, incoming energy can cause particle emission in a nucleus. And there is a constant shuffle of energy within both the systems, leading to occasional escapes. molecules from the liquid and nucleons from the nucleus. So, what do you think? Does this model make it a little easier to understand the mysterious behavior of the nucleus? And what other comparisons can you think of between a nucleus and a liquid drop? Let me know. Thank you for joining.